Good morning, everybody. It's 10 o'clock. Let's go ahead and get started with today's webinar, Tecplot 360. We're going to be going over some major updates that are going to be coming in the next year that I'm really quite excited about. This is work that our development teams have been working on for about the past year and a half, and we're getting close to being able to have beta releases out the door. We actually have a beta release for what we're calling Tecplot 360 MB, which we'll demonstrate today. So let's go ahead and get started. So my name's Scott Fowler. I'm the product manager and executive vice president of Tecplot, and I'll be doing the bulk of the presentation today. I'm also joined by Jared McGarry. Okay, so pretty quick agenda today, two major bullets on the list. We're going to talk about Tecplot 360 MB. The MB it's a little bit tongue-in-cheek, and it's kind of our internal name, and we're using it externally as well to describe some enhancements that really make Tecplot more better, which is again a bit of tongue-in-cheek, but we're having fun with it. And then also talking about a new graphics layer that we're working on for Tecplot 360 and FieldView. So for those of you that may not remember, Tecplot Incorporated purchased the FieldView product a number of years ago, and now our development teams are working together to improve both products. So really neat to see those teams coming together and making improvements together. So what is Tecplot 360 MB all about? As my time as a product manager for Tecplot 360, I've noticed some recurring themes with our customer base, and what we're trying to do is come up with an architecture and a plan to make Tecplot 360 better for these cases. So I've seen people say, hey, Scott, I try to save a layout, but I get this dialog that pops up that says, hey, I need to save my data, and my data is 150 gigabytes, 300 gigabytes, and I just can't afford to write that data back out to disk. It doesn't make sense. So like, okay, how do we solve that? People with transient data. If you've ever tried to use the button in Tecplot 360 that says replace data and retain style, right? You've done all this work to create a nice looking layout, to do some analysis, and then you want to do it with a different data set, and you hit this button, and then Tecplot says, well, I'm sorry, I can't do that because you have transient data. You have data that has what we call strands. So that's how we identify transient data. You know, we need a solution to solve that problem as well. Over the years, we've had people say, hey, variable numbers, zone numbers in layouts and style sheets and macros just aren't that convenient, right? You might have a simulation where your temperature variable was number 8 in one case and your temperature variable is number 9 in another, and then all of a sudden your layout or your macro or your style sheet don't work as expected. So what if we used names instead? Wouldn't that be nice? So in this case, it's pretty clear that variable is particle volume fraction that we're referring to rather than variable number 30, right? Again, if you have transient data, some actions in Tecplot 360, such as extracting slices or calculating a new variable, you might have to wait a long time. So if you have a very long transient case, 1,000 time steps or such, that will cause a really long wait state within the application. So again, how do we make your time more efficient and let Tecplot 360 do the computation when it's time to do the computation? And then finally, as we were thinking about all these other problems, we realized that some of the solution would allow us to add a transient line plot. So that's a line that animates concurrently with 2D and 3D plotting. So we're adding that capability as well. So how are we doing this? We're doing this by introducing 3 new major concepts, and that's what we call the data journal, deferred data operations, and part names. So the data journal, now Tecplot 360 has always had this concept of a data journal, but it hasn't been in the GUI and in your face, and it hasn't applied to all of the data actions that are available in Tecplot 360. So we're elevating this data journal concept to the user interface, and we're adding some capability to it as well. So it's an executable record of operations which add, extract, or modify data. So in this case, in this picture on the right-hand side, you can see that we've done a number of data operations, such as loading a data set, executing an equation, extracting a subregion of my data, doing an integration, etc. And this also provides a visual record of what you've done, and this is editable, which we'll demonstrate later today. Deferred data operations is a concept that allows us to execute the journal only at the time steps that you visit. So if you have, again, a data set with, say, 1,000 time steps, you can set up these data operations, but they only have to get executed for the time steps that you visit. And again, this is going to save you time. So these data operations are deferred until you need them. And then finally, part names. A part is a new concept introduced in Tecplot 360, but it's very much like our old concept of strands. So if you're familiar with transient data, we group zones, which are a single object through time, using something called a strand ID. People have always been a little bit confused. What is a strand ID? And it seems just more natural to use part names. If you go back to that idea of using variable names in a layout, the idea of being able to use a part name in a layout, it removes some of the order dependence of where your objects are. So you can see in this right-hand side, we have an internal combustion case, which has our volume data. It has a piston, a liner, a head, and using these words seems a lot more natural than if you were to open up a layout and see a reference to strand number 2, which would be the piston, or strand number 3, which would be the liner. So names just making a lot more sense. Okay, so with that, I'm just going to jump right into a demo to illustrate these concepts. I have 4 different cases that I'm going to show today, and we'll start with an internal combustion case. I am going to do a little compare and contrast. So what I have here on the left-hand side is Tecplot 360 2024 R1, and what I have on the right-hand side is our new beta, which again we're calling 360 MB because we think it's going to make your life more better. One of the first things you'll notice in the beta version is this data journal, which is over here on the right-hand side. Let me just move it over here. It is a dockable window, so we'll move it over here over the top of the plot sidebar to make the plot a little bit bigger. Now, what I want to do in this case is going back to kind of the keyframe image for this webinar is I want to compute mass flow rate through my exhaust ports. And so the exhaust ports are these 2 objects here towards the back of the geometry. And so in 2024 R1, what I have to do to compute mass flow rate is I have to extract a slice, and I have to extract a slice such that it's isolated to these 2 regions. So let's go ahead and do that. So we'll turn on the slices. I'm going to change it to the Z position, and we'll go into slice details and set it to 0.004. You can see that it's going through both the inlet and the exhaust. To isolate that, we'll go to value blanking, and we're going to change this to x less than 0. All right, and now I have to extract this slice, and I'm going to extract it over all time steps. And now I have to sit here and wait. Now, while that's computing, let's come over here to 360 MB, and we're going to use a new slice dialog. This is still in work. We're still making some improvements here. But we'll just do a slice at the same position just through the cell data. And you can just barely see the slices have shown up here. Now it's going through both the inlet and the exhaust. So we'll use a new feature that we're introducing called extract region. And I'm going to say where x is less than 0, I want to extract that cell data. Okay. And then let's go into CFD Analyzer, just check our gas constant and our field variables are set, and then we can do our mass flow rate integration. I'm going to extract from that last slice and plot the result. And here I'm done. So I've finished my workflow, and I can go back to the plot sidebar and go ahead and hit play. and get a view of my entire mass flow rate through time by hitting play. And if I wanted to do this for every single time step, I could go get a cup of coffee, chat with my colleagues, move on with some other task while Tecplot's doing that computation. With 2024 R1, I had to go through that wait state. Now, this is not a very large data set. So imagine if you had a more complex data set, more time steps, your wait state would be longer. And so you're really just waiting for Tecplot to do computation, and then you have to move on with your workflow. So point being here, we've saved time. We've gotten through an entire workflow, letting Tecplot 360 then do the computation once you're done setting up those steps. We also have a very nice view of the steps that I took. I extracted a slice, I isolated a subregion of that slice, and then I did my integration. And over here, we have no record of that result. One of the other interesting things here with this data journal is it's editable. So let's just highlight the slice that I extracted here. So we'll turn this one on, and we'll change the shade color to red to highlight it. So you can see it's there. Well, let's say I really wanted the integration to go through the intake instead of the exhaust. Well, that's easy enough to do by just going right here and extract region. I can just flip the sign, hit apply, and that's going to move the slice to the intake side. You can see that the integrated result got cleared out. Well, that makes sense because the integration is taking place in a new region, and we need to recalculate the results. And then, of course, I can just go back here and hit play again, and now I have the intake side instead of the exhaust side. So pretty simple to go in there and update and make changes to your result. So now we have a sampling of the intake side. All right, so let's go through another case where we think we've made some nice improvements here. So we'll talk about linear interpolation. Okay, and so what we have here is we have 72 time steps of a store separation case. And in this case, we have values in the volume of the data, but not on the surface. And I want to see these pressure values on the surface. So Tecplot 360 2024 R1, which is not transient aware, right? It hasn't been designed to work very well with transient data, at least for this dialog. So if I want to interpolate from my volume data to my surface data, I'll interpolate to the wall, and then the store, and then I have a couple other surfaces here as well that I can interpolate to. Wall 2, which is this little bit of the pylon, and the boat tail, which is out of view. Right now it's obscured by the slice, but you can see I have to go through the linear interpolation 4 times to get a result. And then jump to the next time step, and I have to do it all over again, but I have to be very careful about which zones I select, right? I have to scroll down here, and let's go wall 9. And then it's going to be error prone as well, right? So over here in the 360 MB beta, we've made some improvements to linear interpolation. So we'll bring up the linear interpolate dialog. And you can see I have a much shorter list because I'm just showing the parts, right? So this represents all of my fluid over all time. We've also made this multi-select. So I can select all 4 of those surface zones, and I'll hit interpolate. And because we have this re-executable journal, this has done it for just this one time step that I'm sitting at, and then I can advance to the next time step and the next time step, and the interpolation is being done as I'm visiting those time steps. So again, a very nice new addition to linear interpolation. Now, let's say, gosh, I really don't need the results on any of these items. I just need it on my wing surface. So I'll just select wall 9, hit apply, and you can see that it's now only on my wing surface. So again, this allows you to edit these actions, where in Tecplot 360 2024 R1, you would effectively have to go back and reload your data to get back to this point. So the 360 MB beta really helps with recovering from errors or modifying actions that you may have performed. All right, one more. We have two more demos actually, so let's jump into a geoscience case. And this is going to demonstrate transient line plots and extracting a line over time. So for those of you who may be from the Northwest, Pacific Northwest, you might recognize the Olympic Peninsula here on the west coast of Washington. This is the Columbia River with Oregon below and Vancouver Island above. This data set is courtesy Pacific Northwest National Labs, which is just down the street from us. We're located in Bellevue, Washington. They're located in Seattle. So in this case, I want to understand the salinity on the surface of the ocean along the Washington coast. So here I'll just draw a polyline down into Oregon here a little bit, select that polyline and say data extract polyline over time. Okay, and again, I have this wait state. This is occurring over all time. Again, pretty small data set, so that wait state wasn't very long. But now let's say I want to draw a line plot of this. So I will add another frame. And we'll flip it to XY line. And on the X-axis, I want salinity. On the Y-axis, this is effectively my latitude. And we'll hit OK. And now this is a static line map. I can't animate it. If I did want to animate this, I could go in and I can create a new set of line maps, one for each linear zone. And now I have a collection of these, and I could go in and say animate the mappings. But you can see that the 3D plot doesn't animate concurrently. If I come back over to the 3D plot and hit animate, the line map doesn't animate concurrently. So there's really no way to get our line map and our 2D or 3D plots to animate concurrently. So let's come over to 360 MB. Go ahead and maximize this so we can see it a little bit better. And we'll do the same sort of thing. And I will also extract this over time. And you'll notice 360 MB, we have this same wait state. That's because not every single action, data modifying action, has been ported to this new architecture. We'll show a slide of which things have and which things have not been ported to this new architecture. In this case, we don't get the benefit of the data journal yet, but it will be coming. But let's look at the transient line maps. So again, we'll create this frame, switch to XY line, and select salinity. And you can see here that on the Create Mappings dialog, we have this new option to say, do I want to select my data by part or by zone? So a zone is a part at a very specific time step, right? So this last zone would be the extracted points at the last time step of my data set. This first one would be the extracted points at the first. This is going to represent all data over all time. So we'll go ahead and hit OK. And you can see that we have transient controls here, and I can immediately go ahead and animate. You'll see that the 3D plot didn't animate concurrently. We go into frame linking. We'll say link solution time, apply, and now they will animate concurrently. If we jump into the mapping style dialog, you'll notice some slight changes here as well. We've changed this area here. This used to say zone, which zone you want it to apply to. In this case, we're looking at parts. So one of the interesting things here that we can do is we can actually compare against, say, a fixed point in time. So if I want to compare my salinity against the data extracted at my first time step, I can say select a zone. This is going to be the data at that first time step in my data set. Let's change the color here to blue, and then animate. So you can see that blue line is static because it's representing the data at one specific time step. You can see it overlaps, proving that it's at that first time step, and then you can animate so you can see both a transient and a very specific, say, a baseline case at the same time. Okay, so that's transient line maps, and again, how transient line maps are using this new concept of a part. So I've talked about a lot of transient cases. Well, what about people with steady state cases? So let's take a look at one final demonstration here. I know that we have quite a few users who use, say, Overflow, which is a code that produces plot3D files. Oftentimes those have just volume data, and to isolate a surface, in this case I have a wing surface, you either have to use complicated blanking, or you have to set in the zone style dialog, set which surfaces you want to plot for each one of those, and it can actually be quite complicated. So I've seen some users use the trick of extracting an isosurface at mach = 0 to define this surface. So let's just walk through that workflow in 2024-R1. And why would you want to extract an isosurface at mach 0? Well, say you want to draw stream traces on it, or you just want another object which represents the surface of the body. So here we'll turn on isosurfaces. I have to go in here and select Mach. Mach is not in this list, so I have to go over to the contour details dialog, and we'll change contour group 1 to Mach. And then we'll set Mach to 0. And now you can see that we have an isosurface that is coincident with that inner boundary. And then finally we'll go to extract isosurface and zone style, and we'll say show selected only. Turn off translucency, and here now I have an actual zone which represents my wing surface, and this will allow me to do something like put stream traces on it. So let's just put some stream traces on this. Right. And now if I go to save this layout, let's say save layout as, just call it delete me. And because the isosurface is not included in the data journal, Tecplot 360 says, hey, I have to save this data to a new file. And this is effectively duplicating the amount of data I have on disk for the purpose of creation of this one new extracted isosurface. So at this point, I'm going to say, no, I don't want to save that because I can't afford to save many gigabytes worth of data out on my disk. And I'll probably go back and write a Tecplot macro. Now, over in 360 MB, we can go through a similar workflow using the isosurface object, but we're actually introducing some changes to extracting isosurfaces. So we have a new dialog that we've created, which you can use optionally, so you don't have to create this transient or ephemeral object first. You can just go straight to isosurface extraction. So let's select the Mach variable. We'll double click in here and say I want an isosurface at 0 and hit extract. And then we can go into zone style, right click, say show selected only. And I immediately have that object, and then we'll turn on the stream traces. UVW. And then, of course, we can now say, save the layout. And do I want to overwrite the one that I already had? Yes, of course I do. And again, this is because we have this slice extraction, which has created new data available right in the data journal. So if I do a new layout and then open that layout, the surface and streams, we're right back to where we were. Now let's say, hey, I actually want, I wanted an isosurface at 0.7 as well. Hit apply, and we can do that. And now we have a couple of isosurfaces. It doesn't look great, but you can see that again, through editing the data journal, you can add new objects, you can delete objects. You know, let's say I didn't want to extract that isosurface at all, I can go ahead and remove it. So that data journal really does offer some nice enhancements. Okay, so that concludes the demo portion. So let's talk about what is currently available in the beta that is available for download right now. We have specify equations. So if you go to the data, alter specify equations and enter an equation, that's available. Linear interpolation, which I demonstrated. Calculate variables. So if you didn't have mock in your data set already, you go to analyze, calculate. That has been added. Perform integration, which we demonstrated. Extracting slice, extracting a region. This is a new capability that we've added in this beta. And then of course, transient line plots. So those are all in this beta and ported to this new architecture. Now, Tecplot 360 has a lot of actions that haven't been ported to this architecture yet. And those are seen here. So say triangulation, zone duplication, extract isosurface is in progress. So that will be available in a future release of the beta. It's nearly done. We just need to get through some QA and some testing phase. So I do encourage people to download the beta. If you encounter any of these features that are limiting your ability to take advantage of Tecplot 360 MB, let us know and we'll prioritize those. We want to hear from you. Okay, so that's it for Tecplot 360 MB. We'll have a slide later that shows you how to download it, where to go get it. But I also want to jump into the new graphics layer. So again, the Tecplot 360 and FieldView teams are working together to update the rendering technology that we're using. This is going to result in faster rendering on all platforms, including Apple Silicon. I know that we have a number of Mac users out there, and it's been a long time coming for us to have an Mac OS Silicon native version of Tecplot 360 that will be coming in 2025. And then this work also opens the door to new rendering technologies such as volume rendering, ray tracing, and oil flow plots. Now, these are not our primary concern right now. The primary concern is to replace the rendering that we have and get it back to parity, and then we can add these new capabilities. So let me show you some initial performance numbers. So these were run on a Linux machine with a fairly current AMD Radeon card. We took a transport airplane and duplicated the data 36 times to achieve these numbers of 74 million nodes, 43 million triangles. And on average, we're about 5 times faster to load this data and get to first image. So if we were to show only the mesh, 2024 R1 took over 50 seconds, and the graphics alpha takes about 35 seconds. Smooth contours and smooth shading, these are going to be the default views that you typically get in Tecplot 360. So when you turn on the contour layer or turn on the shade layer, that's the default. You can see that we went for contouring from over 200 seconds to down to under 50 seconds. So quite a large improvement there. Also for the smooth shading. So these are the most common that you'll probably be using. So drastic improvements. This should also mean that animating to movies, animating to images should be faster because that rendering phase is faster. We've been able to take advantage of some concurrency in our rendering layer, which we weren't previously able to take advantage of, which has also facilitated some of these performance improvements. Now this is frames per second, so interactive rotation. So if you were to grab this view and try rotating it around, translating it around, on average, we're about 22 times faster. And these results were grabbed on a different machine with an older NVIDIA card, maybe a 5 or 6 year old NVIDIA card. So you can see that the performance improvement is quite substantial. So we went from, again, smooth shading is the default view that you would get here. We were at about 2 frames per second to rotate this around. Now we're all the way up to about 45 frames per second. So again, nice advantage. Here's a data set that came from our partners at CPFD from the Barracuda code. This is a case with 2.3 million spherical particles that we're rendering. On the laptop that I'm doing this webinar on, it took 715 seconds with Intel integrated graphics to load and render this plot, and went all the way down to 1.6 seconds with the new graphics layer, so 446 times faster. I can't promise that all of you are going to have 446 times faster performance, but you might get closer down to this 20 to 30 times faster for this type of plot, which is pretty complex. We've done this on, tested this on various configurations. So Windows VM with an NVIDIA Tesla card, 32x faster, Linux with a Radeon Pro, 28x faster. A lot of people out there are still dependent on software rendering, so we wanted to see how that performed. If you're running on an HPC that doesn't have hardware resources, 20 times faster to create this plot. And then again, Mac OS, this went from 42 seconds down to under a second, so 122 times faster to render this plot. So we're really excited about this. This graphics layer work is expected to come out. We should have a beta late this year, and then we're aiming for a release in 2025. The timing might be a little bit earlier for FieldView and a little bit longer for Tecplot 360. Tecplot 360 also has to deal with 2D and XY plots, which adds some complexity on the Tecplot 360 side. So with that, we're looking for beta testers. What's available currently on mytecplot.com. So you do need a Tecplot portal account to access this beta. If you don't have a portal account, you can certainly ask for one. Contact our support staff or our sales staff to get a hold of one, or your internal IT resource who is responsible for downloading Tecplot 360. So what's currently out there is a beta that we released in June, and this is the Tecplot 360 MB work. The graphics capabilities, those are going to be available later this year, and we'll certainly make an announcement of that. So we are really hoping to get more and more beta testers to provide us feedback, because a lot of people say, hey Scott, when are you going to release Tecplot 360 MB? And the answer really is when our beta testers say it's ready for release. So we've done a lot of work internally. We think it's getting close. We probably have a couple 3 months of cleanup work, certainly into Q4 this year, before we think it's fully stable and ready to go. The beta is pretty solid, so I do encourage you to download it and give it a whirl. We've had some people who have had some very nice things to say about it, but we do want some more feedback from our broader user base before we push it out as our official release. Okay, and with that, I'll open it up for questions. We're done with the content for today, so I appreciate your time. We do have one question that came in. So the data journal somehow fixes the need to replace one's data set. Sort of. We've been doing some work to, if we go back up to the initial slides here. So replace data set and retain style. We've done some initial work to make this a smoother experience. It's not done yet in the beta. We are also evaluating the option to, when you open a layout, have an option to select a different data set. So the ultimate answer is yes. The data journal is going to help with that. The beta isn't quite there, but that's our end goal. So again, these major issues that I've heard over and over throughout the years, these are all the things that we're trying to solve, and these are for the most part all solved by these 3 key concepts: the data journal, the deferred operations, and the part names.